Hello. Hi everyone. Today we are solving the structured questions from electrolysis. Previously I uploaded the video on multiple choices. Today we are doing the structured questions. First question. Titanium is a transition element. It is isolated by the following reaction. Now titanium ore, then titanium 4 oxide, titanium 4 chloride, and titanium. Explain why the change titanium 4 chloride to titanium is reduction. So here they're writing it clearly. It is titanium 4. Titanium 4 means it's a oxidation state of titanium, or the charge on titanium. It is plus 4. And to titanium as a metal, its a charge is 0. So basically they're asking why titanium plus 4 becoming titanium 0. That's a metal. That is, why is it reduction? So what we say is, it's gaining electron, or at IGCSE we can say that it's gaining electron. Titanium plus 4 is gaining electron. That would be fine, gaining electron. That is for 1 mark. Otherwise, if someone wants to say in terms of oxidation number, or titanium plus 4 oxidation number is reduced to 0, titanium 0. So oxidation number is reduced from plus 4 to 0. That's also you can claim as reduction. So 1 mark, so that will be just enough to say it gains electron. The following are examples of redox reactions. Bromine water was added to the aqueous sodium sulfite. Explain in terms of electron transfer. You have to talk in terms of electron transfer. Why bromine is the oxidizing agent or oxidant. I use OA, oxidizing agent or oxidant in this reaction. The half equation when you write Br2 is gaining 2 electrons to become 2 Br minus there. That is reduction. So, and S minus 2 becoming S by giving out its 2 electrons. So obviously these 2 electrons from S2 minus taken up by Br2. So bromine is removing 2 electrons from S2 minus. So your answer would be, you have to write Br2 is removing electrons, 2 electrons or generally electrons from S2 minus. So you will be getting 2 marks, removing and electron. It's better to write electron full, electron. So you get 2 marks, removing electrons. So any oxidizing agent will be undergoing reduction. Remember that as well. All right. And one more thing, let me tell you, this is oxidizing agent and this is reducing agent. Always identify oxidizing agent and reducing agent from the reactant side. Never ever try to identify them from the product side, always from the reactant side. All right. And oxidizing agent undergoes reduction, reducing agent undergoes oxidation. Okay. Next question. Aluminum was first isolated in 1827 using sodium. Suggest an explanation why aluminum was very expensive. Then you see aluminum was extracted using sodium. Of course, sodium was, then it was very reactive. I mean, being very reactive and isolation was more difficult. Sodium was very expensive. So if the sodium is very expensive and if you are using that metal to reduce another metal, so that metal become very or much more expensive than sodium. Because, so you write because Na was very expensive. You keep in mind, Charles Morton Hall made aluminum very less expensive or comparatively much cheaper. All right, in modern method, extracting aluminum is the electrolysis of a molten electrolyte, aluminum oxide, dissolved in cryolite. I'm not reading the question full. Give 2 reasons why oxide is dissolved in cryolite. Okay, this question is a repeated regular question. One is to lower the melting point of aluminum oxide. We use that. Hence, to reduce the amount of electricity needed. So, you know, the amount of electricity needed will be reduced. And if the amount of electricity needed will be reduced, the cost of production also will be reduced. That is one. Second one, to increase the ionic mobility. Or you can say it increases the speed or movement. Is it to facilitate the movement of the ions through the electrolyte. That's the reason why it is used. 2 reasons: to lower the melting point, thereby reducing the amount of electricity required, and also to increase the mobility of ions. Which ions we refer to? All the ions, basically aluminum and oxide ions, are the ones we are looking at. Complete the ionic equation for the reaction. You know, this 2 should be over here. So it is 2O2 minus gives O2 plus 4 electrons. Right. O minus 2 becomes O plus 2 electrons. One more O minus 2 becomes 1 oxygen plus 2 electrons. So when we add, it is 2O2 minus becomes O2 plus 4 electrons. That's the explanation. Why do the carbon anodes need to be periodically replaced frequently? Why we have to in extraction of aluminum? Because the oxygen produced, O2 produced at the anode reacts with it. If it is more marks, you will write an equation as well. Carbon reacts with this oxygen to produce carbon dioxide. So it will be slowly getting used up. That's why we need to replace it from time to time. Electrolysis of molten electrolyte. The electrolysis of a molten electrolyte is one method of extracting a metal from its ore. Other methods are the electrolysis of an aqueous solution and the reduction of its oxide by carbon. Explain why these 2 methods cannot be used to extract aluminum. Which 2 methods they are asking? Electrolysis of an aqueous solution of aluminum. Aqueous solution of aluminum will have aluminum ions and H plus ions. All right, so what happens then? The rule says when you have aluminum ions and the H plus ions, from the aqueous solution, only H plus ions undergo reduction, and Al3 plus stays in solution. At IGCSE level, it is enough to say or enough to know that H plus ions will undergo reduction and Al3 plus will stay in solution, because you have a list or a series where you say, please stop calling my African zebra. That's how I remember. Please stop calling my African zebra in my lunch or language class, PB, then copper. This is how we arrange the metal ions, and we place, we say, this is how they are divided into any ion present there. These are very reactive ions. If they are present from aqueous solutions, if these ions and hydrogen ions are present, we are talking about their aqueous solutions. Then the rule is that if this metal ions and hydrogen ion, then it is always hydrogen ion undergoing reduction. And this metal ion and hydrogen ion, or their aqueous solutions, if you take, That will be the metal ion undergoing reduction. H plus stay on. H plus ions will stay on in solution. This rule is just enough for IGCSE for you to remember. Actual reason is with the reduction potentials. That is not really needed at the GCSE for you to explain. Why can't we reduce using carbon? So you say aluminum is too reactive, highly reactive. So carbon can't remove oxygen from Al2O3. Being aluminum is too reactive, carbon cannot gain oxygen from aluminum oxide. That is, these two answers will give you full mark. All right, now you have about 4,000 years ago, the Bronze Age started in Britain. Bronze is an alloy of copper and tin. Copper oxide is reduced to copper, which is then refined. This is refining of copper. Label the diagram of the apparatus which could be used to refine copper. So any metal when refined, this is negative. Negative means cathode and positive terminal is anode. So when it is refined, we always say that impure copper should be at the anode and pure copper strip is usually taken at the cathode, and it's an aqueous solution of CuSO4 you can write, or you can just write Cu2 plus. Minimum you should indicate that it contains copper ions, and aqueous solution of Cu2 plus. If it was another metal, like say for example zinc, then you will say anode is impure zinc, cathode is pure zinc, and electrolyte is, that's a rule always, just remember, aqueous zinc nitrate. If you don't get the soluble compound of that metal, it is wise to always write nitrate of that metal. You know that nitrate of any metal is soluble, so that will be wise. Here, copper sulfate is fine, because copper sulfate is, even otherwise, copper sulfate is soluble in water. Chromium is used to electroplate steel objects. The diagram shows how it could be done. It's something different. Add more chromium 3 sulfate, they show from top, and anode is lead, chromium is plated. All right. Object to be plated is always taken at the cathode. You can see this is negative cathode because metal ions are getting deposited at the cathode. That is why object has to be placed at the cathode. All right, and the solution has chromium sulfate. All right, now the question is, give 2 reasons why steel objects are plated with chromium. Why do we plate? First one, protection. That is protection from rusting. Second one is decoration. Decoration means to have a better look. It gives a better look, appearance to improve the appearance. All right. The formula of chromium ion is Cr3 plus and sulfate is SO4 minus. Give the formula of chromium 3 sulfate. All right, so this is a simple technique. Chromium 3 plus SO4 2 minus. How to write the formula of this compound? Crisscross the charges. So you get chromium sulfate, and the charges are 2 comes for chromium, 3 goes for sulfate. Cr2SO4 thrice. Right. Write the equation for the reaction at the negative electrode. They are referring to this reaction, that is plating. When a metal object is plated with another metal, it's always that metal is getting deposited at the cathode. So they already said chromium is Cr3 plus. So it will be getting enough number of electrons to become chromium. How many electrons? It should be 3. How do you know? 3 plus means it has to be 3 electrons, so chromium. So the equation would be reduction of chromium ions. Sorry. A colorless gas which relights a glowing splint is formed at the positive electrode, anode. Name this gas. So from the description, a colorless gas relights a glowing splint. That's a test for oxygen in IGCSE and even in the higher levels. So that's oxygen. Name the gas. Since they say name the gas, your answer should be written. The name should be written, oxygen. All right. It is not wise to write O2. During the electrolysis, it is necessary to add more chromium 3 sulfate, but during copper plating, using copper anode, it is not necessary to add more copper to sulfate. That's a very good question. We need to explain why when copper is plated. If you're using copper, this is copper anode, and say you're plating it on a ring. This is a cathode. And during the process, copper ions would be formed from the anode, which will be deposited at the cathode. This is what is usually happening. But why in here we don't have to add copper there from top. We don't add copper from outside. Yeah, but in chromium, this particular extraction, see, moving back, they say add more chromium 3 sulfate. Reason is you can clearly see that anode is lead. Lead anode cannot produce chromium ions. So the chromium ions removed from the electrolyte can be replaced only by adding extra chromium 3 sulfate from outside. That's a reason why we need to add extra chromium 3 sulfate. So what we write is we have to give a reason for both. So first one you write the Cr3 plus removed from the electrolyte can't be replaced from Pb anode. So add extra chromium sulfate. But in copper sulfate, copper not sulfate, copper plating, the Cu2 plus removed from the electrolyte is replaced from the anode, from the copper anode. You know, it's the same metal, copper anode. So the removed copper ions from the solution are replaced by ions, positive ions formed from the anode. That's the reason why we don't have to add any extra copper there. Electrolysis of concentrated aqueous sodium chloride between inert electrodes, right, is used to make 4 important chemicals: hydrogen, chlorine, sodium hydroxide, and sodium chloride 1. Ions present are Na plus, H plus, Cl minus, OH minus. How and where you get this? Because aqueous sodium chloride, it is concentrated. Sodium chloride is a strong electrolyte. It splits up into Na plus and Cl minus. H2O is a weak electrolyte. It will split up. That's why we are using reversible arrows, right? So we are using reversible arrow. So you get H plus plus OH minus. All right. Out of this, the hydrogen ions are discharged at the negative electrode. When we have such ions, then we can always choose. The rule says when you have a reactive metal, it will be H plus ions undergoing reduction. And out of Cl minus and OH minus, how do you get which one concentration matters? When it is concentrated, it will be the halide ions, Cl minus. So these are the ions. And in the electrolyte, you have Na plus and OH minus forming NaOH. That is how the electrolysis summary. All right, hydrogen ions are discharged at the negative electrode. Write the equation 4. It's, H plus ions gaining electron and it has to form H2. It's a diatomic. So you need to have 2H plus and 2 electrons. 2H plus 2 electrons gets you H2. All right, so now hydrogen ions are formed from water. Suggest an explanation why concentration of hydroxide ion increases. This is basically as some reference to this equilibrium reaction and to a chapter later, reversible reaction and equilibrium. Suggest an explanation why concentration of hydroxide ion increases. This equilibrium reaction, from here, H plus ions are getting removed. So you say when H plus ions are removed by reduction at the cathode, the equilibrium will be shifted. The equilibrium will be shifted to the right-hand side, RHS, and hence more OH minus will be formed. So 2 marks, 1 mark is to show that in this equilibrium, this is at equilibrium, H plus is removed, one of the products is removed. So the position of equilibrium will be shifted to the right, producing more of the products. So the other one, OH minus, from the beginning, it is not getting removed. Now more and more is getting added as well. That's why its concentration increases. So this is a question from equilibrium. When a dilute solution of sodium chloride is used, chlorine is not formed at the positive electrode. A different gas is formed. Name this gas. As we said, when dilute solution is used, these are the ions, and the rule says when dilute solution is used, it should be OH minus. When concentrated solution is used, it is chloride. Similarly, when dilute solution is used, it should be OH minus. What's the equation for that? 4OH minus gives 2H2O plus O2 plus 4 electrons. So oxygen is a gas. That's what they are asking here. Name this gas. So your answer is oxygen. When they're asking about the name, you need to write the name. State an example of an inert electrode. In the syllabus, frequently they talk about graphite and platinum. So you can write any one of these two, graphite or platinum. It is not advisable to write both, just write one. Because if there is one correct and one wrong, there is a rule, there is an internal negative marking, so you get it cancelled, so you get 0. So why unnecessarily you write a second answer if you're quite convinced with the first one? Next is hydridic acid. Hi is a strong acid. Its salts are iodides. This is again an application type question. In the syllabus, they never talk about hydridic acid. That's not in the syllabus. We talk about hydrochloric acid. So it's in group 7 halogens, HCl, HF, HCl, HBr, and HI. They are all similar. You can just think of. That is a property of elements from the same group. So if you study about HCl, similar properties you can expect from rest of the acids. Right. So by keeping that in mind, let us solve this. HI is called hydroiodic acid. Hydriodic acid, we call it. And the salts are called iodides. It is this reaction of a typical, it has the reactions of a typical strong acid. Complete the following equation. Li plus HI. It's a group 1 metal. So basically you will be getting the product. Lithium iodide, lithium is +1 charge, iodide is -1. Plus hydrogen, I always say it is reactions are MASH reactions, which is MASH stands for metal plus acid gives salt plus hydrogen. So this is how we remember that. So that is one of the reactions of acids, always we say. So Li plus H2, you need to do the balancing. Since there is 2 hydrogen over there, you need to have 2 Hi. Then 2 iodide, you can see, so it is 2 Li. So you have 2 Li. 2 Li plus 2 Hi gives 2 Li plus H2. Next is zinc carbonate plus hydridic acid. Reaction often we write as Cascade reaction. It's a carbonate plus an acid. Write it as Cascade reaction, which is C stands for carbonate plus acid gives S stands for salt plus CO2 plus water. You know, this is why, this is what the expansion of Cascade. So always remember, acids reacting with the carbonate, you can remember with this mnemonic. All right, so here also we are expecting similar salts. So zinc carbonate plus hydridic acid, the salt is already discussed, written down there, they are iodides. So the iodide of zinc iodide plus carbon dioxide plus water. If they have written a portion of it in with a word equation, you have to write, you have to complete it in words. You can't write the formula. You won't get any credit for that. All right, finally, MgO plus Hi. MgO is a good example of a base. So remember, I advise you to remember it as Bash-2O reaction. Bash-2O reaction, B stands for base, plus A stands for acid, gets you S stands for salt, plus H2O. So base plus acid gives salt and water. So from this, you know that MgO plus Hi gives Mgi2. Why do I write Mgi2? Mg is in group 2, so it is 2 plus. Iodide is -1. So when you do the crisscross charges, magnesium 1 and iodine 2. 1 usually we don't write, so it is Mgi2. Plus what? Plus H2O. Now we need to balance it. How do we balance it? You see, there is I2 on the right side and only 1 iodine on the left. So you write 2 hydrogen and 1 oxygen. It's rest of them are balanced. All right. Next question is, 2 of the reactions in A are acid base and 1 is redox. Which one is redox? Explain your choice. One of the rules of redox reactions, when we check the reactions, you can see that carbonate and bases reaction with acids are not redox because there is no change in their oxidation numbers of any of those species. But the first one is redox. Explain your choice. Which one is redox? You know, I'm going to say, okay, lithium plus Hi. Either you can write it this or you can say equation 1 is redox. Why? Because lithium changes its oxidation number from 0 to +1. You know, and it's lithium iodide, it is +1, and lithium here is 0. So 0 to +1. Bracket, you write that is oxidation. You need to write redox, right? And whereas, which one is getting reduced? Hydrogen iodide, hydrogen is +1. So in here, when it is forming an element, all elements have 0 oxidation number. And H plus is reduced to H2. H plus from acid is reduced to H2. So it is oxidation and reduction. So you explained how is it redox. I told you carbonate and base. Those you can just check and see that you know, they are not changing their oxidation states from the once they change to reactants to products. A question to sulfate, next question, is electrolyzed using carbon electrodes. This electrolysis is similar to, be careful, is similar to that of aqueous copper to sulfate. So in the syllabus, it doesn't ask the students to learn about tin sulfate or compounds of tin, but the syllabus talks about copper to sulfate. Students should know about copper to sulfate. So they say, so this is another application question, and you are supposed to apply your knowledge here. So copper to sulfate, you know, tin to sulfate, you should apply the same knowledge to write, which you have done, which you have understood in copper to sulfate to solve this. What is the product at the negative electrode? You know, tin to sulfate. Copper to sulfate, let me first discuss copper to sulfate there. Copper to sulfate, I will have Cu2 plus and SO4 2 minus from copper to sulfate and H plus and OH minus, because these are aqueous solutions, right? So which ions I will choose? Copper ion, because copper is one of the very less reactive metal, or in that list, copper comes very below. So hydrogen would stay and copper ions will undergo reduction. Sulfate and hydroxide, the rule says sulfate will never undergo oxidation. So it is hydroxide ion. So we apply the same idea to tin to sulfate. How do I know what is tin? Look at the periodic table. Tin is Sn. Sn, tin to sulfate is just like that. So it will be Sn2 plus and SO4 2 minus, tin to sulfate, and H plus and OH minus. All right, if you apply the same idea here, you will choose tin and you will choose OH minus. All right, so what is the product of the negative electrode? Negative electrode, it will be always metal or hydrogen. Yeah, here it is metal. So tin metal, Sn metal, right? Sn metal will be the product of the cathode. Write the equation for the reaction at the positive electrode. If you have already taken, already considered, already understood which anion undergoes oxidation, then it is easy for you to write. OH minus, there is one equation. 4OH minus gives 2H2O plus O2 plus 4 electrons. I'll explain it. It is this way. 1 OH minus gives OH plus 1 electron. 1 OH minus will go to the anode to form OH plus 1 electron. You know, OH cannot stay alone. 1 OH will combine with one more OH to form 1 H2O plus 1 oxygen atom. One oxygen atom cannot stay alone. One oxygen atom combines with one more oxygen atom to form one oxygen molecule. When you combine it, all of them, you need 2 oxygen atoms, right? One oxygen atom you get from 2 OHs. One oxygen atom. So how do I get 2 oxygen atoms? I need to have 4 OH minus. It will give 1 O2 plus 2 OHs will give 1 H2O. So 4 OHs will give 2 H2O plus 1 OH will give 1 electron. So 4 OH will give 4 electron. This is how I get that equation. 4 OH minus gives O2 plus 2 H2O plus 4 electrons. If you find it hard to remember, find hard to follow the sequence, you just learn one equation. Out of the whole electrolysis, I recommend students to remember only this equation. Other equations are quite sensible. If you understand the simple redox reactions, it's easy to make. But this one, maybe rather than remembering those 4 steps, it will be easier to remember this one step. All right, name the acid formed in this electrolysis. We continue. Name the acid formed. See, this is the acid formed, which is H2SO4, H plus and SO4 2 minus. Name the acid. So sulfuric acid, you have to write the name. You cannot write the formula. Sulfuric acid. All right. So with that, we finished there. Moving on. Aluminum is extracted by the electrolysis of a molten mixture of aluminum, which is aluminum oxide and cryolite. All right, that is the picture for that. Alumina is obtained from the main ore of aluminum. Name the ore of aluminum. All right, bauxite. That's a straight question. Explain why it is necessary to use a mixture of alumina and cryolite rather than just alumina. Why do we use? We have already answered this. I'm not writing. So answer is that will lower the melting point, and hence we can use less amount of electricity to melt. That can reduce the cost of production. One. Second one, to increase the ionic mobility. Movement of the ions will be increased. Copper can be extracted by the electrolysis of an aqueous solution. Suggest why the electrolysis of aqueous solution cannot be used to extract aluminum. So this question also we have already explained. An aluminum aqueous solution contains these two ions, Al3 plus and H plus, and Al3 plus ion being aluminum being very reactive, Al3 plus ion will stay on solution and H plus undergoes reduction. Whereas from a solution containing copper 2 plus and H plus, copper 2 plus will undergo reduction and H plus will remain. You know, I told you in the beginning, that is the rule with that sequence or the reactivity series itself you can use. That's the order of reduction also it gives, and there is a cutoff line zinc onwards. Those metal ions will undergo reduction if you're taking aqueous solutions. Same idea applies. Since we have already solved them, we are not doing it again. The ions involved in the electrolysis are aluminum and oxide ions. Products of this electrolysis are given on the diagram. Right. Explain how they are formed. Use equations where appropriate. 4 marks. So we have to write equations. What are the products? Products you need to write aluminum, right? That is at the cathode. In the product, only one product at the cathode, but the anode, oxygen and carbon dioxide. So these are the 3 things you are supposed to explain the formation of these 3 things. Okay, so oxygen and carbon dioxide at the anode and aluminum at the cathode. So what do you say at the cathode? Aluminum is formed by the reduction of Al3 plus. Just write the equation. And at the anode, O2 is formed by the oxidation of O2 minus. Equation is 2O2 minus gives you O2 plus 4 electrons. Then you write CO2 is formed when the O2 produced reacts with the anode. C plus O2 gives CO2. If you write these 3 equations, 1, 2, and 3 equations with a bit of explanation, you will get all 4 marks. Yeah, so 4 marks are 1 for equation and 3 marks for explaining 3 product formation, and 1 mark definitely for at least 1 equation, chemical equation. Iron has 2 oxidation states, +2 and +3. There are 2 possible equations for the redox reaction between iron and bromine. Right, indicate in the first equation the change, which is oxidation. Give a reason for your choice. Here, I would say, please know it's an element, so its charge is 0. Bromine charge is 0. Here, it is +2, and here it is -1. Now, I told you even in the last video, you use a number line always to explain redox reactions, oxidation and reduction. How? This is 0, this is +1, +2, +3, +4. And on the other side, you have the negative numbers, -1, -2, -3, -4. Then just remember, increase in the, this is the charge or oxidation number. Increase in the oxidation number or the charge is oxidation. Just keep that in mind. So 0 becoming +2, which is happening here, which is oxidation. Right? What is the question? Indicate in the first equation the change, which is oxidation. So what do you say? I would say you're going to write Fe becomes Fe2 plus, of course, by losing 2 electron it is. Give a reason for your choice. Because it's oxidation, because oxidation is this, because Fe is losing electron. 1 mark for identifying the change, 2nd mark for giving the explanation. Right. Now, which substance in the first oxidation is reductant, reducing agent? Whenever I practice, I write reducing agent, Ra. So this is in the first equation itself we need to, so that the rule is the substance or the species which undergoes oxidation is the reducing agent. And substance which undergoes reduction is the oxidizing agent. Always we identify reducing agents and oxidizing agents only from the reactants, not from the product side. All right. Why? It's a reducing agent. Which substance is a reducing agent? They are just asking Fe. Please never write, never identify or write Fe2 plus, never. That is a product. It's Fe. Yeah, ion. All right, so why is it a reducing agent? Fe is reducing agent because it's giving its electrons for bromine to undergo reduction. Bromine plus 2 electron gives 2 Br minus. Yeah, so Fe is facilitating this reduction reaction. That's why it is reducing agent. The substance or the species which undergoes oxidation will be facilitating reduction. That's why it is reducing agent. But when you write, according to the 2016 syllabus change, they are expecting now students to write because it's giving electrons to the other species. You need to write it. So here you write because Fe is giving 2 electrons to bromine to undergo reduction, okay? Now next. Nickel ores are converted into nickel to oxide. This can be reduced to impure nickel by heating with the carbon. Nickel is purified by the following reversible reaction. Okay, the impure nickel is taken and it is reacted with the carbon monoxide gas and it forms a compound called nickel carbonyl. Suggest another method for refining nickel. Give a brief description of the method. You would suggest a label diagram is acceptable. It's easy for you to identify because we are discussing the topic electrolysis. Otherwise, yeah, still you need to remember many metals. Many metals could be refined. What do you mean by refining? It's a final stage in the metal extraction where partially impure metal, that is basically impure metal, impure metals, the impurity can be removed. After removing the impurity, the pure metal we get, that's a pure metal, maybe sometimes ultra pure metal. That process is called refining, a removal of final traces of impurity from a metal. All right, a labeled diagram is acceptable. Let us try a labeled diagram. So you take, all right, a cell, a container, and you need to take a big fatty anode, usually that's anode, and there is a small thin cathode. This is connected to the anode. Anode is usually the long line. When the notation, cell notation, the long line is for the anode. And then the electrolyte. Then naturally this is positive, this is negative, and this is impure nickel. This side is pure nickel. Cathode is pure nickel. And what's electrolyte? Electrolyte is aqueous NiSO4, nickel sulfate. And as I told you, nickel nitrate would be a good choice for you, because if you don't remember, it's which one is soluble for nickel. Solubility rules, if you don't remember. By any chance, if you don't remember any of that, you say aqueous solution containing Ni2 plus. That's enough. So you are correctly proposing the idea that, okay, solution should have a nickel 2 plus ions in it. How do you remember nickel? The charge of nickel is 2 plus. You don't study nickel in IGCSE. So most of them are transition metals. If you don't remember, you can just write 2 plus. That's a general, most of the most common oxidation state of transition metals is that. Yeah, it is 2 plus. Or else if you're writing, just write what is anode, what's cathode, what's electrolyte. Then you need to write it, the process is electrolysis by the electrolysis, or it is refined by the electrolysis. So 1 mark for saying electrolysis, second mark for suggesting what's anode, what is cathode, and what's electrolyte. Oxidation states of vanadium and in the compounds are vanadium plus 5, vanadium plus 4, vanadium plus 3, vanadium plus 2. It's a typical transition metal. One of the properties of transition metals we learn is they show variable oxidation states. Vanadium 3 ion can behave as an reductant or an oxidant. Indicate in the following equation which reactant is the oxidant. Oxidant or oxidizing agent undergoes reduction, we said. Yeah. This undergoes reduction. 3 plus becomes 2 plus, right? It is 3 plus and it is 2 plus. That is reduction. If that is reduction and that is oxidizing agent, because it makes zinc to lose electron. You know, zinc is becoming Zn2 plus and 2 electrons. These electrons are taken up by vanadium 3 plus. So your answer is indicate the following reaction. Which one is the oxidant? You can, how do you answer this? Because there is no way to answer other than just to circle it. Yeah, because there is no space given. You just circle it and write oxidant. Which of the following equations is, which change in the following equation is oxidation? Explain your choice. 3 plus, see vanadium 3 plus becoming vanadium 4 plus. As you still remember the number line, 3 plus is becoming 4 plus, that is oxidation. So you're right, V3 plus becoming V4 plus is oxidation. Why? Because V3 plus is losing electron. Oil rig, remember? Oil rig. With respect to electrons, always you remember oxidation is losing electron. Rig, reduction is gaining electron. That's how easily you can remember. Ore of aluminum is bauxite, which is impure aluminum oxide. Alumina, pure aluminum oxide, is obtained from bauxite. Aluminum is formed at the cathode when the molten mixture of alumina and chloride, which is Na3Lf6, is electrolyzed. Name 2 products formed at the anode in this electrolysis. Name 2 products. First is, of course, it is oxygen. And this oxygen produces carbon dioxide as well. So these are 2 products, oxygen and carbon dioxide. Sorry. All the aluminum formed comes from the alumina, not chloride. Suggests two reasons why electrolyte must contain chloride. We have already answered it: to reduce the melting point and also to reduce the amount of electricity required by reducing the melting point. Second is to increase ionic mobility. Purification of bauxite uses large amounts of sodium hydroxide. Describe the chemistry of how sodium hydroxide is made from the concentrated aqueous sodium chloride. The description must include at least one ionic equation. 5-mark question. It's an industrial preparation of sodium hydroxide by concentrated. That is one of the uses of electrolysis. If you remember, industrial use, what we call the brine. Brine is concentrated aqueous sodium chloride is called brine. Brine when you electrolyze using graphite electrodes or platinum electrodes. So your answer should be by the electrolysis of concentrated NaCl solution using graphite electrodes. Now, describe the chemistry of how sodium hydroxide is made. So I would say, if you remember, sodium chloride will have Na plus and Cl minus, and H plus and OH minus will be from water, formed from water. H plus will undergo reduction at the cathode, and since it is concentrated solution, Cl minus will be undergoing oxidation at the anode, and in the electrolyte it will be NaOH. So you continue at the anode, Cl minus is oxidized, Cl minus is oxidized, 2Cl minus gives Cl2 plus 2 electrons. At the cathode, H plus is reduced, 2H plus 2 electron gets you H2. In the cell, NaOH is formed. The chemistry of how sodium hydroxide is made from concentrated. So you will get a mark for the anode reaction, you will get a mark for the cathode reaction, and anode and cathode will remove those two ions. That's why Na plus and OH minus will be left behind, which is to form NaOH. That's the third mark. One of them definitely will be from the equations, and electrolysis scores 1 mark. Graphite electrode scores the 5th mark. So you get 1 mark, 2, 3, 4, and 5 marks. It is by, Na plus OH minus gives NaOH. It's 5 marks. You can take 5 minutes and you can write the detailed description of it. Definitely you should have the process electrolysis mentioned, and also the graphite electrode also, then the reactions in the electrodes. Making sodium hydroxide from sodium chloride produces 2 other chemicals. Name these 2 chemicals and state one use of each chemical. First one is, it's name, hydrogen. What's the use of hydrogen? To produce ammonia or to make margarines, or you can also say it is used as a fuel. Second chemical is, you can say chlorine, name, so you need to write in words. Chlorine for making bleaching powder, then or for the purification of drinking water, or also you can say for making also for the put in the as a bleaching powder. It can be used in swimming pools, and also as chlorine directly, we can say it is used in swimming pools. Water purification could be at two different ways. You can say drinking water we use in air and water chapter. We talk about it. It's killing germs and bacteria to that level where it could be used for drinking. Whereas in swimming pool, also it is used for the same reason. It is killing germs. During the electrolysis, ions move in the electrolyte and electrons move in the external circuit. Please remember, that's a good point. Few times they have asked in the multiple choice questions as well. Ions are moving in the electrolyte here and electrons are moving in the external circuit. This external circuit, it is a movement of electrons. All right. The diagram shows the electrolysis of molten lithium iodide. Okay. What's the question? The diagram shows 6A. I think the page is missing here because it doesn't look like it is connected. Let me just see the question. The reactivity series can be written as a list of ionic equations. Right. Most reactive metal, they say they have given a list and there is some ions or some part is missing. Most reactive metal, the best reductant. Okay. Most reactive metal is the best reductant. All right. Explain why the positive ions are likely to be oxidant. Positive ions, they can gain electron. If the substances can gain electron, means they can undergo reduction. So they are good oxidizing agents. If they can gain electron from something else, so they can gain electron. So they are good oxidant. Deduce which ion is the best oxidant. You know, even here, some metal which is more reactive than this, maybe aluminum gives aluminum 3 plus 3 electrons. This is how we complete it. Most reactive metal is the best reductant. So this is the best reductant. So there's a best oxidant would be from the other side. These are all oxidant because they are positive ions. They are oxidant, oxidizing agent. These are reducing agent. This is the most reactive metal. So very readily it undergoes this reaction. As you come down, the reactivity decreases and silver won't easily become silver ion. Or other words, I can say silver ions will be readily becoming more readily or most readily out of this will reverse it by gaining electron. So the best oxidant would be Ag plus 1. So in such a series, once again, let me tell you, metal ions are best reducing agent. And if aluminum was there, aluminum is the best among all of them, most reactive metal. They said it here, most reactive metal is the best reducing agent. So out of the lowest or the least reactive metal ion will be the strongest oxidizing agent. These are all oxidizing agents. Remember that. This question they have asked it twice or thrice in the past papers. I have seen it. Which ion is in the list can oxidize metal, lead metal? These are oxidizing agents, right? So which one can oxidize the lead metal? Anything below these two can oxidize the lead metal. So if you react Pb plus Cu2 plus, the reaction will take place and you will get Pb2 plus Cu. It's getting oxidized. Why? Because Pb is more reactive than copper, we say. That's why this displacement reaction can take place. So this is the oxidizing agent. So you can say copper 2 plus or Ag plus. You just need to write 1. Yeah. Is the best oxidizing agent. Oh, no, it's not there. It is here. So one of those two you can write. Best oxidizing agent is only a silver, and answer to V is either of these two. All right, next is solid aluminum oxide is a poor conductor of electricity. It conducts either when molten or when dissolved in molten chloride. Explain why. Why solid iron is a poor conductor of electricity? 2 marks, so you need to explain it. It's an ionic compound, right? So when solid or in solid state, the ions are not free to move. Ions are not free to move. That's why they can't conduct electricity. But in molten or in aqueous, molten, when it is molten or aqueous, ions are free to move. So the same idea, the ability of ions to move and conduct. That's what we need to highlight there. Why is a solution of aluminum oxide in molten cryolite used rather than molten aluminum oxide alone? Since they are comparing the molten state, best answer would be the speed or ionic mobility. Movement of the ion will be more smooth when it is mixed with, because they are comparing molten. So you can say that bring down the melting point, but since already they are comparing the melting point, it is better to talk about the ionic movement. Movement of the aluminum and oxide ions will be much more fast when mixed with the cryolite. Explain why the carbon anodes are to be replaced periodically. Because carbon anode reacts with the oxygen produced at the anode. Please do specify. The anode reacts with the oxygen produced at the anode. It's not the oxygen from the atmosphere, it's the oxygen produced at the anode. One reason why graphite is used for the electrodes is that it's a good conductor of electricity. Give another reason. Second reason is it is inert or doesn't react, unreactive. Yeah, that's the reason why it is used. Aluminum is used for making food containers because it resists corrosion. Explain why it is not attacked by the acids in food. It has a non-porous coating of Al2O3 aluminum oxide, which is a protective coating, or which doesn't react with the acid under room condition, which doesn't react with the food acids under room temperature. This reaction doesn't take place. Non-porous, it doesn't reach to the subsequent layers. It is non-porous, or it's a continuous layer. It protects the further layers. So that is why food acid doesn't react. Aluminum is very reactive, but aluminum is used in so many cooking utensils because of this. It has a protective coating of aluminum oxide. Aluminum is used for overhead power cables, which usually have a steel core. Give 2 properties of aluminum which makes it suitable for this use. Why is it for the power cables? Very good conductor of electricity, that's the first thing. Very good conductor. Second one is it has no corrosion, right? No corrosion. So many other properties also you can write. It's very ductile, or it has very low density. It's comparatively much cheaper than copper. These are all the properties. There are so many properties together making aluminum as a very good choice. But the first one you should say it's a very good conductor. Yeah. Second one you can say it doesn't corrode. Its weight is less as well. Its density, I should say, density is low. Explain why the cables have a steel core. In order to strengthen it, to increase the strength. Increase the strength. Otherwise, it is not as strong. Aluminum has limited strength. So in order to increase the strength, we are using a steel core. Otherwise, it will snap. It will sag and snap. In order to prevent that, we are using steel core. A method being developed to produce iron with lower emission of carbon dioxide is by electrolysis. Hematite is dissolved in molten lithium carbonate and electrolyzed. The ore is split into its constituent elements. Write an equation for the reaction at the negative electrode. you know, they are giving you an example or giving a different scenario which matches with something you have learned already. It is quite similar to Al2O3, right? Fe2O3 is quite similar to Al2O3. You know Al2O3, aluminum oxide. So you can apply the same idea here as well. Write an equation for the reaction, the negative electrode cathode. Cathode is metal. So the ions are similarly Fe3 plus and O minus 2. So you have to write the equation with the Fe3 plus at the cathode. Fe3 plus, definitely taking up 3 electrons to become Fe. Complete the equation for the reaction of the positive electrode. 2O2 minus gives O2 plus 4 electrons. That's quite easy if you know these equations. If you practice a few times. Equations, please do practice. Write, and learn. Define in terms of electron transfer, what is oxidation? Just remember oil rig. Oxidation is losing electron. Losing electron. Explain why the positive ions in the above equations are oxidizing agents. Okay, that is something which is not connected with the above equation. It may be some equation, I would say, Zn2 plus maybe Fe gets you. It's the other way around. This reaction doesn't take place, right? So you should take Zn plus Fe2 plus gets you Zn2 plus Fe. Here, Y is the positive ion oxidizing agent. Basically, isn't it zinc is getting oxidized? Zn becoming Zn2 plus 2 electron. Cn2 plus and 2 electrons. These two electrons are gained by Fe2 plus. So why is it an oxidizing agent? Because it is removing electrons from the other metal. Or yeah, because it is removing electrons from whatever species it's given with. Our equation was Fe2 plus Zn. So we say it's removing electron from, if this was the equation, you will say zinc. It is removing electron from zinc. If it was something else, then depending on that situation, you will choose. Next. The solution of zinc sulfate is electrolyzed using inert electrodes. This electrolysis is similar to that of copper to sulfate. Do you remember just previously we have done tin sulfate, now it is zinc sulfate, similar to copper to sulfate. Write an equation for the reaction at the negative electrode. Negative electrode is always metal. So zinc sulfate, if it is zinc sulfate, you have Zn2 plus and SO4 2 minus and H plus and OH minus. Since it is similar to zinc, it has to be these two undergoing reaction. So the equation, the negative electrode is zinc plus 2 electron gets you zinc. Complete the equation for the reaction at the positive electrode. 4OH minus gives 2H2 plus O2 plus 4 electrons. Yep. The electrolyte changes from zinc sulfate to, it is this one. This is what is in the electrolyte. Sulfuric acid. Sulfuric acid. You can write the name or the formula here because they didn't specify the name. They just said 2. So you can write the formula also. Displacement reactions are redox reactions. On the following equation, draw a ring around the reducing agent and an arrow to show the change, which is oxidation. Which is oxidation? Isn't it? Oh, no. Which is oxidation? Isn't it this oxidation? Oxidation. So we should not draw the ring. Ring is only on one thing, which is, now, yeah, this is oxidation. Basically, we say this is oxidation. So this is reducing agent. Yeah, right. They're asking, draw a ring around reducing agent. So the ring is here. Yeah. Initially, what we said was correct. ring is on zinc because that's a reducing agent which removes electron. So it provides electrons for Pb2 plus to undergo reduction. Complete the following ionic equation. Zn plus 2Ag plus gives. Of course, zinc is more reactive, so zinc will displace Zn2 plus 2Ag. Zinc ions, always 2 plus charge. Chlorine is made by the electrolysis of concentrated aqueous sodium chloride. Describe this electrolysis, write ionic equation for the reactions at the electrodes and name the sodium compound formed. A few questions before, we did the same question again. Just take the ions Na plus, Cl minus, H plus and OH minus. Then you choose H plus and Cl minus. Then you say, oh, the sodium compound formed is sodium hydroxide. And then write the reaction at the anode, cathode, and then just revise or look back at the video. Just you just pause it and see it again, or you may try by yourself this time. Aluminum is obtained from purified alumina, Al2O3, by electrolysis. Alumina is obtained from the main ore of aluminum. State the name of its ore, bauxite. Describe the extraction of aluminum from alumina. Include the electrolyte, the electrodes, and the reactions at the electrodes. 6 marks. Electrolyte. So let us answer. Electrolyte, you should write molten mixture of Al2O3 plus cryolite. You get 2 marks for that. Electrodes. Next is electrodes. Graphite, positive and negative both. Anode and cathode both are electrodes. Reactions. Just write the ions. It will be easy if you are listing down the ions. The ions are Al3 plus and O2 minus. Anode reaction. Always its anode is positive and oxidation. O2 minus, 2O2 minus gives O2 plus 4 electrons. Then some oxygen produced there will react with the carbon to form carbon dioxide as well. Now that's anode reaction. Now cathode. Cathode reaction is, cathode is negative and it's always reduction. How do you write the equation? Aluminum plus 3 electrons, aluminum ion plus 3 electrons gets you Al. So you get it. So you get the marks 1, 2, 3, 4, molten mixture of 5 and 6. That's how you get 6 marks. All right. That's a good question. Always prepare aluminum and iron extraction for sure in your exam. It's alternatively they're repeating or most repeated extractions. Out of 3, 2 of them, it's almost a sure question if you can learn these 2. Aluminum is resistant corrosion. It is protected by an oxide layer on its surface. The thickness of the oxide layer can be increased by anodizing. State the use of aluminum due to this resistance of corrosion. Food containers, always they say food containers is due to this resistance of corrosion. Or also you can say the window frames, poly house frames, etc. They are all due to resistance of corrosion is the main reason why we use. Anodizing is an electrolytic process. You know, anodizing is a process where aluminum objects get an extra coating of aluminum oxide. Dilute sulfuric acid is electrolyzed with an aluminum object at the anode. The thickness of the oxide layer is increased. Complete the equation for the reaction of the aluminum anode. OH minus gives O2 plus 2H2 plus 4 electron. So you basically write 4 OH minus that equation, 4 electrons. That is reaction taking place at the anode. Then aluminum plus dash gives aluminum oxide. Of course, it is oxygen. This oxygen produced. Now you need to balance it. you have 2 oxygen here and 3 oxygen there. In order to balance it, you have to make even number, one even and odd number. You double the odd number so that you get the even number. So I doubled that side of O3, so it became 6. So now 4 aluminum on the left and 3 O2 also on the left to balance it. All right. Now next, aluminum is obtained by the reduction of aluminum ions to aluminum atoms. Write an equation for the reduction of aluminum ion to an aluminum atom. It's a repeat question. Quite a few times we have written plus 3 electrons gets you Al. If you solve this worksheet by yourself, you will be definitely going over these equations again and again. That's a good way of revising, a good way of remembering stuff. Original method for extracting aluminum involved the reduction of aluminum chloride using the reactive metal sodium. That's before this electrolysis, okay? Aluminum is obtained by this method was very expensive due to the high cost of extracting sodium from sodium chloride. So sodium was very expensive because it had high cost. Complete the equation for this reaction. Yeah, aluminum, sodium is more reactive. So it will take away chlorine from there. It releases aluminum and sodium chloride will be the product. How do we balance it? 3 chlorine, so you need to have 3 sodium chloride, so 3 Na. How can sodium metal be obtained from sodium chloride? It is just a question, and how do you answer it? How can we get sodium from sodium chloride? Electrolysis of 1 mark. Electrolysis of next mark is molten sodium chloride. So that is the 2 mark. 1 mark for saying electrolysis, 2nd mark for saying molten compound. Because you know that from aqueous solutions, we will never get this kind of reactive metals. Yeah, this could be the last question for us. Reaction between calcium and nitrogen to form calcium nitride is a redox reaction. In terms of electron transfer, explain why calcium is a reducing agent. Let us just see. Calcium plus nitrogen to form calcium nitride. CaN, the charges are 2 plus 3 minus. So 3 for calcium. So it is this way, Ca plus 2 and nitride is N minus 3. So 3 goes for calcium, N for 2 for nitrogen. So I should write here CaN and the numbers Ca3, N2. N2. In terms of electron transfer, explain why calcium is the reducing agent. And it's a metal non-metal reaction. So calcium becomes Ca2 plus 2 electrons. Nitrogen, of course, gaining electrons to become N minus 3. If you want to write a balanced equation, N2 plus 6 electron gives 2N3, N minus 3. Yeah, right. Now the question is explain why calcium is a reducing agent. So calcium is providing electrons for nitrogen to undergo reduction. That's your answer. So in there, what you write is why calcium is. So I would say, if I'm writing, I'll write calcium becomes Ca2 plus 2 electrons, and nitrogen plus N2 plus 6 electron gets 2N minus 3. Since it is a metal non-metal reaction, you can always say that metal calcium loses or gives electrons to N2. So it is a reducing agent. The marks will be definitely loses electron to nitrogen. These are the 3 marks. So with this, we stop this structured part of the electrolysis questions. I hope you understand. If you understood, if you didn't understand, you can write a comment and I will explain further in the next video. Thank you.